Good morning.
Morning.
What? Oh,
Good
was it already
morning.
open? Oh, it was already
Hello.
open. Whoops. I am just fucking up everywhere. Okay. Yeah, so, yesterday we did some things. Don't quite remember what. But today we're gonna do even more things. So that's gonna be cool. I was thinking we'd have a look at movements today. Just a little bit of base. We're just gonna do some basic car stuff. It's not gonna be anything, not anything super extreme, but I think it's something fun, something I like doing, and it also teaches us a little bit about how some engine features work. So I think it's a good exercise to do, even though perhaps in your game projects and so on, perhaps you wouldn't make your own movement from scratch because that's really hard, especially if it's something like a platformer or something that's quite complex movement and not just that 2D car game where you just go forward or not. But it's still a good way to learn some things. So I thought that's what we're gonna do today. And maybe some UI if we have time. Who knows? Just upping there we go. Follow speed a little bit. All right. So the first thing we want to do is change so it just doesn't go forward automatically. We actually want to like control it somehow. So we're gonna send in the input from the pawn into the gosh darn movement component, so that the movement component knows which buttons we're pressing. Alright? So let's do that. Let's fucking go. So I'm gonna make a float. That's gonna be our drive forward input. Let's just start there. So I added a drive forward input to the car movement components. And then we're gonna, instead of adding actor world offset, which is the hard coded 500, instead I'm gonna do that using the drive forward. Holy hell. Well, I fucked up. So let's just try that again. Add actor world. Owner add actor world offset. F vector forward vector times drive forward input times. And what happens with speed? So maybe we can make that a U property, because why not? So I'll make a U property here. And speed is not something I want to change in the editor, or not in the editor, in the level. I don't want to be able to change the speed on each individual car. So I'm going to make that edit defaults only. Let's make a category for it as well. I make category car. No. Driving. Yeah, that makes sense. So the speed variable here. Whoops. And there we go. So now we're gonna be moving forward, in the world forward in this case, I guess, times the drive forward input times the speed times the delta time. What a nice equation we got here. Oh, it looks so good. So to make this work, we of course have to feed in this drive forward input from the pawn. So let's do that. So in the race car, here in a handle accelerate input, whoops, I am going to feed that into our movement components. So in here I'll just set move comp drive forward input equals value. And that's it. So just feeding in our handle accelerate input into the movement components. Easy. So let's restart. Are you guys tired?
Super tired.
That's
Yeah.
good. That's
Yes.
No.
good. No? Who said that? Was it you, David?
Fake news.
You get out of here. You're expelled. Only tired people are allowed. Okay, so now when I play, so it doesn't go, but if I W, then we start going. So that's good. That looks pretty neat. And of course, now we can go into this blueprint version of the car and hit the movement components, and we should have driving here. Yeah, the driving as a category, and we have speed. So we can change, like, oh, I want to boost the speed up a little bit. So now it goes super fast. Even our camera can't even keep up with him. Okay. Let's revert. That was a little bit too fast. I'm just gonna revert this back to 500. Right. So now we have that. So let's do turning then. So I'll make a new variable called turn speed. Like that. I have no godly idea. Let's do 180. I don't know. It's degrees per second. And then we want to add drive, turn input, or steer input. Maybe steer input would be good. I don't know. Is that Kitty? What is his name?
His name is Kissen.
That's a
Worst
great
name ever.
That's
It's like naming him Cat.
Yeah, it really is like, oh, you're so good, Cat. I love you, Cat. That's a good name.
We adopted him, so it was his name, so we couldn't really change it.
Is there any laws for changing kitty names? I feel like you should be able to call him what you like. Oh, Optimus Prime. You're so good to me. Alright, so we're gonna do add active world rotation. And I'm gonna use this rotator one, because we want to yaw the vehicle, right? So when you're turning, you want to turn around the Z axis like this. So this is yawing. So we want to yaw this bad boy. So it's gonna do add active world rotation, and then we'll make a rotator. And here we can see the parameters, which for some reason they're not aligned with the axes. I would assume it was like roll, pitch, yaw for X, Y, and Z, but for some reason they decided not to do that. So instead it's pitch, then yaw, then roll. So I don't know. I don't know. So we don't want to pitch, but we do want to yaw. We want to yaw with drive, steer, input, times turn speed, times delta time. And then 0 for the roll. And that's gonna be it. That's steering. So same there, we have to feed in the input, this drive steer input from the pawn. So we're gonna do race car. And then for this handle turn right input, we're just gonna do move comp, drive steer inputs equal to value.
In the movement component CPP file, right now we're like caching the owner every tick. Could we technically like just cache the actor owner directly just at begin play, or is there a special reason why we have to fetch it?
We could do that.
Okay.
In the end, it's cached already. So I mean, this get owner. Crap. It just kind of returns this owner private variable. So I mean, it's already cached. So we don't need to worry about that. But we could do that. But then
Cool.
I guess we technically would have two. We would have two owners there. But yes, that's a good thinking. I like your thoughts. All right, guys. While this is compiling, I want to ask you guys a very important question. Who would win in a fight? Me versus 1 trillion lions. Who would win?
You.
You? Me?
No.
You don't think I would win?
Lions.
I think it would be close.
Yeah.
Okay, additional information. I have a stick that I found that looks like exactly like a sword.
Whoa.
I'm
And
gonna
Dude.
race car CPP real quick.
okay.
That's rare.
Race car. Yeah, it has like a hilt and everything. So I think I would take them on.
Racecar.h.
No, I didn't change anything in here, but that's what it looks like.
Okay.
Okay, so now if I hit the turn buttons, then wow, and we can drift. We don't go anywhere, but it's cool. All right. So obviously we want the car to go in like the current forward vector rather than the the world forward vector when we're hitting forward. So
Great idea.
Yeah, thanks. Yeah, I'm a game designer, by the way. So I'm gonna use, instead of doing F vector forward vector here, instead I'm just gonna do owner get actor forward vector. There we go. We could also change this to add actor local offsets if you want to, if you're one of those people. Which again will transform this delta location to the actor's world space before moving. So if you hit forward vector here, then it will move in the actor's forward vector. But I don't mind this. This is cool. Let's try it. Let's see if I can go. So now, if I drive forward and I turn and I drive forward, wow. We are playing a car game. This is like actually driving a car. I feel like I feel like I'm driving a car in real life right now.
I believe I'm speaking for Daniel as well when I say whoa.
I do feel like
Yes,
Daniel
as
has
by
like he has
associate.
2 responses. He has whoa, and he has true.
True. It's true.
All right, cool. So we have the the bare minimum of anything. So let's spice it up because this is kind of boring. Obviously, it doesn't really feel all that good. So let's make it just a tad bit more physical. So instead of just adding adding a location like this, so it's like as soon as I stop hitting W, I stop. Which I would be honest, doesn't really feel like a car. I mean, I know I'm being a little bit self-critical here, but it doesn't really feel exactly like a car would feel. We also turn in place, which I don't know if cars can do that. I've never driven a car in real life, so I'm not actually sure. But I've seen in movies a car or two, and it doesn't. I don't think they can do this. So yeah. So let's So we got the input in there, but let's actually make it feel good. So what I'm gonna do is that additionally, I'm gonna add a velocity vector. There's an F vector. So vector in this case is not an array. That would be T array. We haven't really talked about arrays or stuff like that at all. I think at some point we will, but yeah, this is what arrays looks like. They're actually called arrays and not vectors. So that's thank you, Unreal. This is just a mathematical vector. So we're gonna add a velocity vector here. Let's set it to F vector 0 vector. It's by default, why not? It's good to be thorough. And then instead of having a speed, we're gonna have an acceleration. Okay? Acceleration. Oh. So then what we're gonna do in tick, instead of just adding active whirl offsets like cretins, we're gonna do something quite similar to what we did in, you remember the STL course when we did the platformer? We're gonna do some physics, baby. Physics! And it's very easy to do. We just call make physics happen. Yeah, like that. No, I'm just kidding. Let's apply acceleration. It was a joke, by the way. The reason I said that because you didn't laugh. So we're gonna do velocity plus equals. Was that a laugh? Yeah, next time try again, but care. So we gotta do order get actor forward vector times acceleration times drive forward input times delta time. So instead of just adding an active whirl offset, instead we're adding an acceleration to the velocity, right? So we're just increasing the velocity rather than actually moving the car at all. And then we're gonna do apply movement. Whoops. Whoops. And then instead of applying active world offset with this active forward vector times blah blah blah, instead what we're gonna do is just apply the velocity times delta time. Very
How
easy.
did you delete everything in the parentheses like
It's
that?
a Vim thing.
Oh god.
So, sorry. You guys should learn Vim, it's great. It only takes like half a year.
Takes 10 years.
Yeah, and they could be as cool as I am. And I'm very cool. I go up to girls at bars and say like, "Hey, I know Vim," and they're like, "Oh, Emil, tell me your favorite command." It's like, "It's DD, baby. I use DD all the time." All right, so we're applying a world offset with velocity now. How great! How great! I'm very tired today. I was tired yesterday, but I'm even tireder today. So it's gonna be a fucking. I'm just gonna ramble a lot. So get fucking ready for that. All right. I don't want any fucking complaints about that. Okay. If I see on the YouTube video that people say I ramble, I will ban them. I don't know if you can ban on YouTube. I'm assuming you can ban on YouTube, but I don't know. Okay, so now we're using the velocity instead. So now if I hit W, we should slowly speed up. And if I hit the S key, we can slow down. So now we have a little bit more realistic game. So if I hit W, we keep rolling. Then if I hit S, then we also keep rolling. If I turn though, we get some weirdness, right? If I turn while I'm moving, of course the velocity won't update to be in the direction of the car. And it's very slip and slidey, right? We're in the ice level here. So if I try to like drive around like this, it becomes very hard. So we're not quite there yet, I would say. We still have a few steps to go, I would say, before we have like an actual good car. But we're getting there. Now we can actually do drift. Look at this. Tokyo Drift, baby. Oh, I was off screen. Tokyo Drift. That's cool. All right. So the first thing I want to add is friction, right? Because right now we have the problem of like if I speed up, I'll just keep speeding up forever. So I'll just keep going faster and faster and faster forever, and there's no max limit on that. And also if I release the W key, of course I will never stop. There's no point where I will actually stop, so I can that doesn't really make sense. I have to break the stop. That doesn't make any sense. So we're gonna start adding some friction here. Where's my car? There it is. And this is exactly again the same. I don't remember what the fucking redo command is in Vim. I never used the Vim redo. I thought it was Shift R, but it is Control R. Control R. Oh, that's not bound. Oh fuck. What was this? Acceleration. Okay. And then here we're gonna do friction. So friction will be the higher the number, the faster it's gonna slow down. I would pick maybe 1.8 for now. It's probably good. So then we're gonna apply friction after our acceleration. Whoops. So we do that with velocity minus equals velocity times friction times delta time. So remember we talked about this kind of briefly in the STL platforming thingy majig, so I won't talk about it too much right now. This was the exponential friction that I talked about. Where the faster we're going, the higher the friction is gonna be. Instead of constant friction, which is bad. Objectively bad, I'm saying that. But yeah, very common, very common pattern for making stuff feel quite physical. It's just this simple acceleration friction function. The method algorithm. So now if I drive and release W, we actually slow down. Isn't that nice? Meep meep. Alright, now we're actually going quite slow. I might want to up the acceleration a little bit now that we have such a high friction. Might also actually want to lower the friction a bit. So you know what? I'm actually gonna go in here. So I went to do the BP version of the car. I'm gonna hit the movement component. And I turn the friction down a little bit. Let's do 0.8. I'm gonna up the acceleration just a little bit, so I'll do 800 for the acceleration there. Alright, that feels pretty okay. Might even want to lower it a little bit, but then it would become icy. And that's the second problem I kind of want to fix now. Is that, you know, the way that wheels work, right? I know I'm going a little bit advanced here, but the way the wheels work is that they roll, right? It's kind of... Yeah, I know we haven't really thought about it. Like, scientists are still kind of figuring out what wheels are. But yeah, I think I understand that they roll. And that's how the friction goes down. So, let me paint you a picture here. So when a car is moving like this, and the wheels are kind of pointed forwards. This is velocity, right? If the when the velocity is sort of aligned with the wheels forward vector, then we have quite low friction because the wheels are rolling. So that's why we have that's why cars go, because the wheels roll, which lowers the friction. Essentially, yeah, I know I'm quite smart. The problem though is, of course, if we're going this way, this is kind of the downside of wheels. If we're going sideways, suddenly the wheels can't roll anymore, because they can't roll sideways. Amazingly, it's kind of a big design flaw with wheels here. They can't roll sideways, so that means they will be slipping. Right, the wheels are slipping. That's kind of when you talk about the grip of wheels. And that's why you can't drive a car sideways. Because the wheels just don't turn that way. You have fundamentally misunderstood how wheels work. So we kind of have two frictions, right? We have the forward frictions, or the aligned friction, which is the wheels turning. Oh, wheels keep on turning. And then we have the sideways frictions, which is sort of the grip friction, right? It's the grip of the wheels when they're sort of sliding against the ground. So that would be the grip friction. The grip. And let's call it friction roll, and then friction grip. friction grip. So to simulate this amazing scientific understanding of how wheels work, we're gonna have to split up our friction forces. So right now we're just applying one friction force, right? There's one force pushing back against the car, that is just friction, just flat F. But instead we have to do two. We have to do two separate friction calculations. We have to do one for the velocity that is pointing along with the wheel, which is the rolling. And then we have to do one friction calculation for the grip. So we have to split our velocity up into aligned velocity versus perpendicular velocity, and then we have to sort of, do math on those separately and then recombine them, and that's gonna be our final velocity. So let's do that then. Here's me. Here's the car window. Here's me. I'm wearing sunglasses. I always look up at the sky, by the way, when I'm driving. Just looking at God, being like, do you see
Put
me?
on the seatbelt. Emma, put on the seatbelt. Thank you.
And here's a box. Okay, and I don't know what the fuck am I doing? Okay, so let's let's do that then. So we're gonna keep the acceleration. That's gonna be fine. We don't have to change that. Then have a friction. We're gonna have to split this up. So what I'm gonna do is that I'm gonna make two friction variables. We're gonna have rolling friction, and then we're gonna have grip friction. So we're gonna have, let's do 0.8 for the rolling, and then for the gripping, we'll do some high number. Let's say our wheels have quite a big amount of grip, so we'll do 3.8. It's quite a high number. Big wheels keep on turning. Yeah, so then we want to split up our velocity, right? So we want to have rolling velocity. So what's our rolling velocity gonna be? So if we have some velocity, that's bad. Okay. So if we have some total velocity, right? Then we want to split this up into two components. So we want to have the part of the velocity that aligns with our forward vector. So we're going to constrain this velocity to our forward vector, like so. So this is going to be our rolling velocity. And then we want to constrain our velocity to the grip direction, which is the perpendicular. So that's going to be our grip velocity. So we're going to split our velocity up into two components. And then the important part is that if we add them together, so if we have the velocity rolling and velocity gripping, if we do VR plus VG, that should equal V. Right? We should split them up in a way where if we recombine them, we should get V back. And of course, if we see this now, yeah, if we have VR, so we go over here and then we add VG, then we get V. So that's what we're gonna do. So let's constrain then. Is there a project? Yeah, there is. Okay. So we're gonna project onto get a copy of this vector projected onto the input vector. Ah, perfect. So we're gonna use this project onto. Wait, that's a member function. Whoops. Velocity project onto, and we're gonna project that onto the get actor forward vector. Big wheels keep on turning. And we can actually deduce from this equation here how to get the grip velocity. We could do another project if we wanted to. But since we have such a simple equation, we have used like VR plus VG equals V. To get the grip, we can actually just rearrange this equation a little bit. I know math is just insanely difficult, but I'm just gonna minus VR on both sides. So that we get VG is equal to V minus VR. And that makes sense, because we're taking away this projection, like we're taking away the part that aligns with the rolling direction. So we take V minus this VR vector, so we step back here. So V minus VR will give us VG. And that makes sense, because these are perpendicular, right? And we're taking away from V every part that is aligning with our forward vector. The remaining velocity should always align with not the forward vector. So get VG. So let's do that. So grip velocity is going to be equal to velocity minus rolling velocity. How nice. How nice. How sweet. How absolutely sweet. So now we can actually apply our friction separately. So now we can do rolling velocity minus equals rolling velocity times roll friction times delta time, and grip velocity minus equals grip velocity times grip friction times delta time. So we're still using like the exponential friction. It's not exponential. I don't know why I keep saying that. It's linear. It's linear friction. We're still using the linear friction. Just doing it twice on two different vectors. And then we're just gonna apply, and then we're just gonna recombine them to get our new velocity after all the friction has been added. Velocity plus grip velocity. There we go. So split the vector up, apply friction, and then recombine. And hopefully what this means is that after the friction has combined, or after the friction has been applied, I mean, the grip velocity should have shrunk by more because we're applying a higher friction than the rolling velocity. So the rolling velocity should stay roughly the same, while the grip velocity has shrunk quite a lot. Oh my god. And it's of course because the wheels want to go forward. Like that's the way they preferentially want to go, and they don't really want to go perpendicular because that they can't roll that way. So let's try it then. Let's go then. All right. So now if I use release, then I keep rolling for quite a while. Just like a car. But if I do sort of a hard stop where I sort of turn 90 degrees like this, then we stop almost instantly. So we do like a sliding, like a cool slide. And now turning also, we can see that it works much better. So if I turn, I must much more quickly start actually going in that direction. Rather than just like doing this wide arc. We still kind of do a wide arc because we still have quite low frictions on both of them. But most likely I would make the grip friction a lot higher. We're still kind of feeling a little bit like we're on ice. Actually, let's do that. Big wheels keep on turning. Let's do like 5.8. So I'm upping the grip friction quite a lot. Yeah, so now the turning radius is much smaller. Cool. Man, the camera is just not keeping up. Let's just speed up the camera a bit. Let's see. Here, follow speed. It's up at the 5. Much better. Cool. Very simple, very simple car equations. Just the way I would normally do things for stuff that needs to feel physical without actually doing any physics calculations. Like this, like we're not taking the wheels into account, like essentially at all. Like we're not caring at all, like where they are, if they're in contact with the ground or anything. It's just kind of just go forward. We'll get into stuff like collision and stuff in just a little while, but just to get the car feeling okay, I think we did a great job. We still have some problems, right? Yeah, we can turn in place. So let's fix that so we don't turn in place. But first, let's take a break. Kind of also want to, you know what, before we do that, I'm just going to add something to the windshield just so we see what the front is. I'm just going to add a little box. In the beginning, at the start of the car here. Whoops. Let's turn off snapping a little bit. Whoops. There we go. Kind of looks like the back, but that's the forward. Let's make it green. God, that's an ugly ass car. There we go. Now we can see where we're actually going, so that's nice. All right. Let's take a break. I'll see you guys back 11:10.
Could you show the acceleration line again?
Yes.
Awesome, thanks.
Emil, are you there?
Hey.
Yeah, I think some of us had some crash issue, which maybe we could look into.
Oh no.
Yeah, I posted in the chat where we get some sort of exception, access violation, blah blah blah.
Access
Because,
violation.
yeah, I think move comp is like inaccessible or like not created properly, which triggers an error when they try to call
Where did you post it?
in the chat.
I don't see anything in chat. Could you post it in Discord instead? I don't think my Teams chat is working.
Emil, just learn to use Teams, please.
Ruta, please learn to.
You just click on it and it opens, and then big actually.
Click on it and it opens. It doesn't work for me, Ruta. I'm telling you.
Are you sure?
Yes.
Wait, Emil, did you start it through the client and join as guest?
Yes.
Okay, yes. I had the same issue where I can't see the chat.
See this?
But if you open it in the web browser, you
Oh
can
my
see
god,
the
what
chat.
the fuck is wrong with this? Okay, Emil, just delete Teams, please.
Okay, let's see. Access violation. Oh no. Okay. Could you run in debug mode so we can see what actually is going wrong?
I suppose I'll share screen.
Yeah.
Oops, that was the wrong one.
Oopsie poopsie.
Place the player. Okay, wait, debug mode.
Yeah, well, you have to restart the engine. You're just making new maps.
Yeah, it doesn't save.
No, yeah, start from Visual Studio.
Oh, wait.
Just hit F5.
My God, why doesn't the system make new saves maps every time?
Because you keep saving it.
Yeah, but
you don't have it as
why?
a startup map, I don't think.
Oh, okay, yeah. Right. So is it on right now?
Yep.
Okay. I think I'll have to compile real quick.
Oh, I don't. Oh, okay.
Yeah.
Then play.
It's probably break everything. Immediately.
Okay, so this move comp was null pointer.
Yeah.
Okay, can I see your header file?
Here.
Okay, that's strange. If you restart, so it's Control Shift F5.
There were some other people having this issue too, right?
Well, I saw some crashes, but it was usually with the camera, because we didn't do a null pointer check on the camera's photo target. But if you look on the race car before you start, look in the components there on the right. Yeah, you just don't have a movement component on it.
Wait. This one has it.
Yeah, you do have it there.
Okay, dokie. Nice.
That's weird.
Is there something with this? Visible anywhere?
No, this looks right to me. Yeah, I'm wondering if it has anything to do with hot compiling.
Yeah, I've been hot compiling way too much.
Yes, it's very cursed. But yeah, so it seems like okay. So if you delete your Amogus
Gone.
and then drag out
Forever.
another one, yeah, it doesn't have it. Okay, try this then. So close down the engine. Yeah, you just yeah. Then go into your folder in Visual Studio.
It was. Yeah.
Then go to the root of the project. It's like outside of source there. Yeah, and then use nuke. So close down Visual Studio first, actually.
Fuck, where did I put it? It's here.
But I see it in
there.
in the recent, but okay. And then use shift delete the intermediate folder.
Okay.
Yeah.
It's a bit nuclear, but okay.
Yes, just nuke it. Alright, and then regenerate project files. Alright, and then open up the SLM file again. Okay, and then run F5. Oh, you have to set the FG racing game as the startup project
Where?
in the Solution Explorer.
Where?
To the right.
Oh, here.
Yeah, right click FG racing game. Then set a startup project. Yep. And then F5.
Build started.
Yeah, you have hidden your output window. It's like super tiny on the bottom, so I can't really see what's going on with the build, but I'm guessing it's just building.
There we go.
Okay. Alright, and if you drag out my race car now, what will happen? Okay, I think your blueprint is just broken. I'm gonna be honest with you. Make a new one and see if that works.
My new Lamborghini.
Yeah. Okay, and just add a cube or something, I don't know. Yeah, sure. And then drag that out. Yeah, that has the move component. Yeah. This is what happens when you hot compile. Your blueprints get just fucked up beyond belief. So
yeah. But I didn't quite catch how you set up the line coding. It just says
yeah, I don't know. Like
Huh?
Yeah,
now it worked.
There now it's up, and then you can hit Control Alt F11. But even that is like it won't work in all cases. And it's kind of tricky to know like when will it work and when will it not work. So I would seriously suggest like if you want to be safe and make sure it works, then just open up from Visual Studio, and then like whenever you make a change, just restart. It only takes like 10 seconds. So
Only.
yeah, so I mean that's really what I would recommend.
All right.
Because you get bugs like this, and that's really hard to debug, to know like, did I do something wrong, or is it just like hot compiler being bad?
Yeah.
So
I like that one of the main features is just like fundamentally broken.
yeah, I mean,
why would you click the big button that says compile? Why would you do that, idiot?
Yeah, it's dumb. It's dumb. It
But
is what it is.
Yep.
All right. All right. Yeah. So, where were we? Yeah. So we don't want to be able to turn in place. That's not really how cars work, because again, the wheels are moving perpendicular to the rolling direction, which is not allowed in real life. Hasn't unfortunately been patched yet. So the way that actual cars work, right, is that when you turn, the wheels are turned like this, the front wheels. Which means that when the car is rolling, these wheels want to drive this way. Which makes the front of the car sort of turn to the left. It sort of it sort of moves the front of the car a little bit to the left. The important part of this is, of course, if the car isn't moving, so if the car is just standing still, this won't do anything. Because, of course, the wheels can only turn when they're actually rolling, because that's when this sort of displacement is happening. We're going to make a super oversimplified case of this. We're not actually going to do the wheels or anything like that. We're just going to observe the fact that when the car is moving, that's when it turns. And the faster you move, the more you turn. So it's sort of like instead of having a flat turn speed, like 180, instead we're going to turn that into some sort of how many degrees per unit traveled are you turning. So if we actually made the wheels, we have to like, okay, so what's the turn angle of the wheels? Like how much can they turn from just facing straight forward? And like how big are the wheels? That's going to become important, and blah, blah, blah. Instead, we're going to just condense that to one flat value, saying like how many degrees per unit traveled do you turn? So that means if we're traveling a greater number of units per second, as in we're going faster, we're going to turn more. And if our unit is 0, or if our velocity is 0, we're not going to be traveling at all, which means we're also not going to be turning at all. So this turn speed, we're going to use this as a turn, as a degrees per unit. So then when we're rotating, we're actually going to do drive steering input times turn speed times, and I'm going to make a speed here. Speed is equal to velocity size. So dot size will just give us the length of the vector. And the length of the vector is, of course, our speed. So we're just going to do multiply by speed here, and that's it. So now if we're going at 0 speed, this should be 0, which means this whole equation should become 0. And the faster we go, the bigger this number is gonna get. So let's try it then. So now if I hit the turn buttons, nothing happens. Okay, so that's good. So we can't turn while standing still. And if I start moving and then turn... Okay, oh god! I'm being sucked in! Yeah, so maybe we have a little bit too fast turn rates. It's a little bit hard to control. So yeah, of course, we set this to 180. So that's going to be 180 degrees per unit traveled. And of course, 1 unit is 1 centimeter. So for every centimeter we go forwards, we're going to turn 180 degrees, which is quite a lot. I don't think cars can actually do that. So we're going to turn this down a lot to be 0. I don't know, let's do 0.5 perhaps. I have no good mental image about what a good number would be, but definitely smaller than 180. So let's do 0.5. So now, for every unit we travel, we're gonna turn 0.5 degrees. Alright, that feels okay. It's a little bit fast, perhaps. Yeah, it's a little bit fast. So now I can only actually turn when I start moving, and when I slow down, you can see my turning speed decreasing. So that's pretty good. It's a little bit fast though. It's a little bit too snappy for my taste. So let's bring that down a little bit. So I'm just gonna go into BP and change it. I'm just like switching up a little bit when I'm changing in BP and when I'm changing in C++, but that's the way. That's the name of the game, baby. So let's do 0.3. That feels pretty alright. Nice. Yeah, I think the acceleration right now is perhaps a. I think the rolling velocity or the rolling the rolling friction plus the acceleration does feel quite great. It's a little bit, yeah, it's a little bit weird, and like it should probably accelerate a little bit slower, but also the friction should probably be a little bit lower as well. But whatever. You're also turning from the middle, like the pivot point for the car is in the middle, which also doesn't really make any sense in real life. You know, in real life, as the car is turning, the pivot point will be the 2 back wheels, because they're the ones that are touching the ground. So when the car swings around with its front wheels, that it's gonna swing around like this with the back wheels as the pivot points. But of course, we're just rotating the actor, and right now we've set the center point of the actor to be in the center of the car. So that's gonna be the pivot point. So we're gonna be rotating, you know, like this, which doesn't really make sense, but I'll slap that up to a good enough approximation of what a car does, I would say. So it still isn't great. Like when we turn, we slow down quite a lot. Like even though you would expect in like a racing game that that turning wouldn't be quite this extreme. But then we're gonna have to start talking about like, okay, when you turn, you have to like sort of redirect the velocity and stuff, and it's like whatever. It's too much work. This will be a solid good enough, I think. We're just gonna keep it like this. Just keep it simple. All right, so I think we're ready to turn into to start moving into collision checking then. start doing that junk.
Could you show your values for the acceleration and friction?
Yes.
Cool, thanks.
Boom. So, you know what? I'm gonna take an executive decision here. My brain is just completely fried. So let's just take an early lunch. There we go. I'm just gonna call an early lunch on this. And I'm gonna lay in bed for a while and just contemplate my life a little bit.
Hell yeah.
Yeah, so I would assume you guys aren't too opposed to that. So let's take actually a longer lunch. Let's do 1.5 hours. Just so you don't, so you guys like still come back at 1 if you have stuff planned or whatever. So let's do so let's take lunch now and then reconvene at 1. So take a little bit of a longer lunch because I need a little bit of a longer lunch. And then we'll step into, because collision checking is gonna be such a fucking huge topic, and I don't feel ready for it. I'm not mentally there, so I'm just gonna eat some good fucking lunch. I'm gonna pump myself up, gonna drink some Red Bull, and then we'll come back and we'll do fucking collision checking, baby, and it's gonna be quite sick. So enjoy a nice long lunch, and I'll see you guys back at 1. All right.
Can you just show the code?
Yes.
Or leave the code or something?
Yeah, I'll leave the code up. All right, cool. So see you guys soon. Bye-bye. Whoops, I didn't mean to leave. Since you guys still want to see the code, sorry. Okay, be right back. See you at 1.